In this video, we are going to solve question number 17 of TIFR 2021. The question basically asks, consider the following chemical reactions in gas phase. So I have reactions 1, H plus deuterium, and the product is HD plus D. The reaction 2, deuterium atom plus hydrogen molecule that produces HD plus hydrogen atom. Which of the following statements is true? So reaction 1 is endothermic, reaction 2 is endothermic. Reaction 1 is endothermic, reaction 2 is exothermic. So we need to talk about here whether which reactions is exothermic or endothermic. So let's talk about how to do it. So enthalpy of reaction, that is delta R H, which is denoted by delta H P, the formation enthalpy of the product minus delta H R, that means the formation enthalpy of the reactant, that is enthalpy of reaction. So what's happening in the first reactions? H plus D2 to HD plus D, H plus D2 HD plus D. So delta R H1, so enthalpy of the reactions for the first reactions, okay, so that will be delta F H, product means here HD, minus delta F H D2, right? Here we are considering the bond enthalpy, okay. So as there is no bond in deuterium atom, so and here also hydrogen, so we can ignore it, okay. Next one is the second reactions is D plus H2 and that will be DH or HD plus H, and here we can say delta R H2 will be delta F H, and the product is DH or HD minus delta F H, and here it is hydrogen, okay. So now we can say that energy of bond formation of HD, HH and DD is reverse of the bond dissociation energy of this molecule, and at 0 point energy depends on stretching frequency, okay. So 0 point energy depends on stretching frequency, which decreases with increase in reduced mass, so that we can say the order of stretching frequency will be HH greater than HD greater than DD, right? So we can say that the delta H1 that that was the formation enthalpy of HD minus formation of enthalpy of DD, and here we can say that the formation enthalpy of DD is greater, okay, because when DD is formed then large amount of energy is released, okay. Why this is so? If we consider the energy profile diagram, then we know here that this is like frequency, or we can relate it with energy, and this is reaction coordinate. So when dd will be formed, as well as the frequency, staging frequency of the dd is lower, so dd will be placed here, then hd, then hh. So which has lower in energy? dd. So when deuterium molecule will be formed, then lots of energy will be released as it has lower in energy. Okay, so you can say that the formation enthalpy of dd will be more negative. So delta H of dd will be more negative than hd, or then we can say delta H hd, right? So if this becomes more negative, then minus of this will be positive, right? And it is also negative, so here it is negative, here it will be positive. Minus and minus means positive. So overall, if we see, then delta H1, the first reactions will be positive. For example, let us suppose delta HDD, let's say this one is minus 10, and delta HHD, let's say this one is minus 5. Okay, then what will happen? This will be minus 5, then minus of minus 10. So overall it will be plus 5. Okay, so this is how delta RH1, that means the heat of the reactions for the first heat of the reaction of the first one is positive. Now let's check. We know that when HH bond is formed, then the energy is released, but when HD bond is formed, then greater amount of energy will be released as HD is in lower energy. So delta formation of HD will be more negative. It will be more negative than this one. For example, delta FHHD is minus 10, and this is, let's say, same, minus 5. Okay, so what will happen from this equation? We will have minus 10 minus of, it is minus 5, so overall it will be minus 5. So delta RH2 will be negative. So we have found out that delta H, the first reaction, is positive, and delta H, second reactions, will be negative. Now delta RH1 positive means this is endothermic, and here it is minus, that means exothermic, means heat is released or energy is released. Okay, now let's check which options is matching with us. So the first reaction is endothermic and the second reaction is exothermic. So option number B is matching. Okay, thank you so much.